Hey everyone, just wanted to welcome you to week 7, module 7 for ME12 dynamics course. So in this week, we're going to take a look here. What we have due is our quiz number 7. This has been posted to Blackboard and will be due on Friday the 16th by 4 p.m. You also have your new homework. Homework number 3 is now assigned. It is on Blackboard as well. This will be released on Monday, October 12th at 6 a.m. and will be due on Monday, October 19th the following week by 11 p.m. Please reference the homework guidelines for details on format, grading, and submission. At this point, you've already done 2 homeworks and 1 exam, so you should have a really good idea of what we're expecting for that format and how the grading is done. If you have any questions outside of what's covered in these homework guidelines, please feel free to reach out to me. Again, my office hours are Tuesdays and Wednesday mornings from 9:30 to 10:30 a.m. But if that does not work for you, please just message me on Teams or send me an email, and I'll find a time to meet up with you to go through any questions you may have. So in Module 7, we're going to be taking a look at the kinetics of a particle, impulse, and momentum. And we're going to look at impact, along with the relation between force and angular momentum covered in Chapter 15 of your text. So once we complete this module, you should be able to develop the principle of linear impulse and momentum for a particle and apply it to solve problems that involve force, velocity, and time. We're also going to study the conservation of linear momentum for particles and analyze the mechanics of impact. We'll also introduce the concept of angular impulse and momentum, and then go through and solve problems involving steady fluid streams and propulsion with variable mass. For your required readings for this chapter here, you can take a look at Chapter 15's Section 4, 5, 6, and 7. So those are your required readings. I encourage you to do those before starting any of your quizzes or homeworks, or even looking through the lecture slides. Get a good background on the subject material by reading through those sections in your textbook. Assignments for this week here. Homework number 3 is going to be assigned, and it's going to be due on the 19th by 11 p.m. And reading quiz number 7 is going to be assigned and due by the 16th, Friday by 4 p.m. So we're going to break this module down in different sections. Section 1, 7.1 here, we're going to look at impact. So objectives within this section here, we're going to understand and analyze the mechanics of an impact. We're also going to analyze the motion of bodies undergoing a collision in both central and oblique cases of the impact. So through this here lecture slides, we're going to look at some applications. We're going to take a look at central impact, talk about the coefficient of restitution, oblique impacts, and go through some problem solving. One of the applications here, we can see the quality of a tennis ball is measured by the height of its bounce. So this can be quantified by the coefficient of restitution of the ball. So if the height from which the ball is dropped and its height of its resulting bounce are both known, we can then use that information to determine our coefficient of restitution of the ball. So we move on to the second section here, Module 7.2. We're going to take a look at angular momentum and momentum of a force and angular impulse and momentum principles within this section here. Some of the objectives we're going to look at here is we're going to want to be able to determine the angular momentum of a particle and apply the principle of angular impulse and momentum. We're also going to use conservation of angular momentum to solve some problems. So within this section here, we'll take a look at some applications, go over angular momentum, take a look at angular impulse and momentum principle, take a look also at the conservation of angular momentum, and go through some problem solving. So if we talk about some of the applications for this section here, one thing that we have is we know that planets and satellites move in these elliptical orbits. So this motion is caused by the gravitational attraction forces. So since these forces are going to act in pairs, the sum of the moments of the forces acting on the system will then be 0. This is going to be helpful when we're solving some of these problems. This means and lets us know that the angular momentum is going to be conserved.